Cool. So this week's class, we're going to focus on everything visual. So everything's super visual, and then next week we're going to go into the fundamentals of coding. So let's start off with some terms and some definitions to get out of the way. So we have pixels, and you might hear these terms interchangeably. Pixels, screen sizes, resolutions, DPI, points. Let's start off with the most basic element when it comes to user interface, the pixel, right? So the pixel is the smallest element in the user interface, and it's really just a dot, right? And the dot is backed by three colors. It can be red, it can be green, it can be blue, or I guess it can be alpha as well. So basically, with the combination of red, green, and blue, you can have millions of possibilities on what this pixel can be. So the pixel is really like the atom, right? It's the smallest unit in the screen, in the user interface. Screen size, when we talk about screen size, we give it typically inches, and we measure diagonally. So we measure like this. So this can be, you hear of iPhones being 5-inch or 4.7-inch. And then I always wonder if they measure like horizontally or vertically, or how they do it. It's diagonal. The screen size is measured diagonally. When we talk about resolutions, we talk about how many pixels are there horizontally and how many pixels are there vertically. So if my MacBook Pro is 1200 by 800 pixels, I'm saying that there's 1200 of these pixels packed together horizontally, and there's 800 of these pixels packed together vertically. So this is 1200, and this is 800. So that's resolution. Something that you guys might not be too familiar with is DPI or PPI, dots per inch or pixels per inch. And that's exactly what the acronym implies. In a given physical inch, how many pixels are in that space? And that's the DPI. So as you can imagine, if you have a higher DPI, that means you have higher pixels jammed in the same physical space, so you have better quality. And points is what we use in OS. So we use points as how we measure the width and the height and the X and the Y of elements. And we'll get to why we use points in the next slides. So again, pixel is the most fundamental element when it comes to user interface. By having the combination of red, green, and blue, you can have millions of possibilities. iPhone sizes is measured diagonally. So the original iPhone was 3.5 inch, and then it got bigger and bigger. And this is the iPhone 6 Plus, which is 5.5 inch. Another slide showing you the same thing, just different iPhones with different iPhone screen sizes. And then I just realized 20 minutes ago, Trina drew the slide in here. She compared the iPhones to a Pop-Tart. So that's cool. So Pop-Tart is 9.2 inch, in case you didn't know. So there's that. All right, so resolutions, so some numbers. If we're looking at an iPhone 5, there's 640 pixels horizontally, and there's 1,136 pixels vertically. And as you can tell, as your screen sizes grow bigger and bigger, naturally you're going to have more pixels because you have more real estate. So again, DPI is in a given physical inch, how many pixels is crammed in that inch. And if you have more pixels, you have higher quality. So a higher DPI means the clearer the quality. So all together now, these are 3 phones with 3 different screen sizes, 4.7, 5.5 inch, 3 different resolutions. Right here, you can see in the second, there you go. Here, this is the resolution. And then at the bottom, you have the points per inch, or the dots per inch. How many pixels are crammed in a physical inch? So in an iPhone 5, there's 361 pixels in a given inch. While in an iPhone 6 Plus, it's higher res, it's higher quality. So there's more pixels in a given inch. So when understanding user interface, like these terminologies are actually really important to understand. A lot of people jump into building iOS apps and they don't really have a firm understanding of like these basic terminologies. So that's why we have these slides here. So if I were to go to Interface Builder and I were to just throw a box in there, in Interface Builder, it would tell you that the position of this is 20, 20, and it will give you like a width and a height of 50, 50. The coordinate system works such that the origin is on the top left. So that's kind of different than a Cartesian coordinate system where it's in the center. The coordinate system in iOS it starts in the top left, and that's because it's decisive. So that's the rule of the coordinate system. So the origin is always at 0, 0 right here, and positive x goes this way, positive x, and positive y goes this way. So if I were to place a box right here, the origin of this box is 20 points to the right, 20 points to the bottom, and it has a width and a height of 50 points by 50 points. So right off the bat, this might be kind of foreign to you guys because notice that I used the word points and I didn't use the word pixels. This is not 20 by 20 pixels, 50 by 50 pixels. It's points. So to understand why iOS has chosen to use points instead of pixels, we can go back in the day when the first iPhone came out. I think it was, let's see here, it had a resolution of 320. So that was fine. Everyone was happy with a super low res phone back in the day because they didn't know any better. So the first iPhone had this resolution. When the iPhone 4 came out, one of the biggest things that they advertised was that it had the Retina display. And what they meant was there's twice as many pixels in the same physical space. So this is the iPhone 4. And it has 960 by 640. So that actually has a lot of implications for developers because this is the same screen size, but there's twice as many pixels jammed into it. That means if I had a box right here, and let's say I use pixels, if I have a box here that's 50 by 50 pixels, it would look this small in a device. So this is 50 by 50 pixels. It would look smaller in a high-res device because there's more pixels in the same space, right? So this is 50 by 50 pixels. It looks this big to you physically. 50 by 50 pixels in an iPhone 4 with Retina display with twice the resolution, it would be much smaller because there's just more pixels in the same space. So it's very clear that at this point, when the iPhone 4 came out, that we can't use pixels, right? If you design something that you think would look like this, but actually looks much smaller on a high-res device, or vice versa, you're going to run into a lot of complaints and bad user experience. I decided to just not use pixels because down the road, right? So nowadays we have like the iPad Pro, right, or the iPad Mini. These devices have even higher DPIs than the original iPhones. So that you want the box to look this big, and you want it to look this big as well on an iPhone 4. You want it to look this big as well and this big as well on an iPad Pro and iPad Mini, even though they have different DPIs. With the iPad Pro having the most pixels in the same per inch. So they invented the point system. And the point system is pretty straightforward. 1 point is equal to 1/72 of an inch. So if you have 72 points, it's 1 inch. So now they're actually using physical space to measure the dimensions of these views. So 1 point is 1/72 of an inch, which means 72 points is equal to 1 inch. So by doing that, I can say that, let's say I have a box right here, and I want this to be 72 points by 72 points. This box will be 1 inch by 1 inch in any device, in all the devices, because that's the measurement. It's not related to pixels anymore. So it's abstracted away from pixels. And Android has something similar to this. Android has DIP, density independent pixels. So with Android and with iOS, we both abstract away this concept of pixel because we know that different devices have different screen densities. So for you guys, when you're developing your user interfaces and your images, you basically have to have the proper way to do it would be to have one image and have 3 different sizes. And one size that's for the display of the iPhone, one image size for the display of iPhone 4 to iPhone 6s, and then one for the iPhone 6 plus, S and Plus. So if I have an image, so if I have an image here, it's 500 by 500 pixels, and I want this to look like this on an iPhone 6 Plus. I need to make another image that is half of that, so 250 by 250. Right now, that. Okay, the easier way would be to work my way up actually. So let's say 500. Let's just say 100. And then this is for an iPhone. If I want to display this image on an iPhone 4 to 6s, then this image would be 200 by 200 pixels. And if I want to display this on a iPhone 6s Plus, then it would be 300 by 300 pixels. Because you want the image to look the same on different devices with different screen densities. So it would make sense that you have different images with higher pixel count. So typically, you're supposed to have all 3. And if I have an image called avatar, so avatar.png, you would name it, if you were displaying this in an iPhone 4 to 6s, you would display it in what we call 2x resolution. So you would name your file avatar at 2x.png. And if you want to display this on a very high-res iPhone, then you would display it in what we call 3x resolution. Then you would name your same file avatar at 3x.png. So as mobile developers, we care about interfaces. As iOS developers, we care about how things are presented across different devices. So we would have for every image, we need 3 slices in 3 different image qualities, so that it can look the best it can in different devices with different screen densities. So you guys might not be too happy about that, but I can show you that Android is worse. I'll prove to you. Android image size. Android, you have like so many more devices, right? You have to account for so many things. And because of that, you actually have to slice your image in 1, 2, 3, 4, 5, 6 ways, right? So for every image, you actually have to slice your Android asset into 6 different variations. And the names are kind of funny, right? So low, medium, high, extra, extra, high, extra, extra high. Whereas with iOS, you really have 1x, 2x, 3x. The proper way is to do all 3, but really no one really uses an iPhone nowadays. Like I'm talking about the original iPhone. So no one really cares about 1x in reality. So you would have images that are either 2x or 3x. So you typically don't even have to have 3 different versions of your images. You only have 2. Does anyone have any questions about that? Yeah.
So if you only had like the highest quality, what would it look like on the lower?
iOS is smart enough to try to scale it. It would try to take, so it would actually be smart enough to take at 3x and scale it to 100 by 100. However, let's say this is, I don't know, like let's say this is 500 kilobytes, this is 250 kilobytes, this is 100 kilobytes. If you only have that one image, your app size would be a lot bigger. If you have different images, then iOS would actually provide different images at runtime. So it's much more performant to do the work beforehand and not have one giant image and have iOS resolve it. It can resolve it, but for performance reasons, you want to do this. And these are the things that that a lot of companies really care about. It's like, how do you make apps performant? Sure, you can throw in the highest res, but it's going to be at a performance hit when it comes to memory. Any questions about that? Okay. Okay. So every single thing you see in the screen is a view, and a view has what we call a frame. And a view's frame is basically the x and the y, which is the origin, and the width and the height. The width and the height, which is the size. Every visual element in iOS is expressed as a rectangular shape, where you have an origin and then you have a width and height. That's what that slide is saying. So continuing along with images, there's really three contenders when it comes to images. There's three formats. One of them is GIF. I'm sure you guys have seen a lot of GIFs. It's popular because it's limited to 256 colors. So that's 1 byte. That's 8 bits. Because it's limited in how much colors it provides, it takes less memory footprint. And it's also a very popular format for animations, so Giphy. So that's all I have to say about that. It supports transparency, and notice that it's small files. It's small because the amount of colors that is possible through GIF is limited. JPEGs are really popular for pictures. Whenever you take pictures from the iPhone, it saves it internally as a JPEG. It's known for having a lot of different combinations of colors, millions of combinations of colors. You can't save JPEG files with a transparent background, so that's something that's really important. And then the compression algorithm, we're not going to go too much into it, but it's lossy compression, meaning every time that you compress the JPEG, some quality is lost in the process. So if you write a function that infinitely compresses the JPEG, you would have like a blur. You would, it would be so distorted. On the other hand, PNG is a lossless compression, meaning you can keep compressing it and there's no data that's going to be lost in the process. It's super popular because of it allows transparency. So you can save images with a transparent background in PNG, but not JPEG. And like JPEG, it also offers millions of varieties of colors. So this is just a rundown on all three, pinning them side by side. So in iOS, we would recommend you guys use PNG as much as possible. The system is optimized to process PNGs. However, if you have like someone's profile picture, you can use JPEGs. JPEGs are meant for photography. All right, so this isn't a design class, but why not? Let's give you guys some tips. The first tip of designing a great app is to hire someone. I thought it was kind of funny. Hire a professional graphic designer. So don't do it yourself. Well, just kidding. We'll talk more about designs later on. You guys can read this guideline if you feel like this isn't super important. If you want to design great apps, just keep it simple, keep it minimalistic, strive for that very clean UI. for app icons, so that app icon you see in the home screen, you are not supposed to create app icons with the rounded edges. Apple actually crops it for you. So when you submit your app icons, you can actually submit a square image, and Apple would do the cropping for you. Don't include a drop shadow. Don't try to be clever and use transparency or like shine or gloss, or just don't make it ugly. Just keep it simple, a square image, and something like this. Some more guidelines: no text, don't add text, confuses people. So you can just read those guidelines for app icons. Yeah, so you can submit an app icon like that, and then when you actually run it in the home screen, it would appear as if the edges are cut off, because iOS does that for you. So remember how I told you guys that, for every image, you actually have to have different qualities of the images for different screen densities. For app icons, it's no different. You actually need to have different app icons. You have the same design, but you have different sizes. So you want your app icon to show on the iOS notification system. You want like a smaller one. For an iOS 5 and 6, it's going to be lower quality than an iPhone 7 to 10. And then on the Spotlight, you can see that it's 40 points, and right here it's 29 points. So really quickly, how you do the math is, if it's 57 point, then 1x means, it was on the slide, but all right. So when we say 1x quality, we mean 1 pixel is equal to 1 point. When we say 2x quality, we mean 2 pixels is 1 point. And when we say 3x quality, we mean 3 pixels is equal to 1 point. So 3x is the highest quality, right? So 1 point is equal to 3 pixels that are jammed into 1 point. So that's the ratio. So when you look at this, this right here says 60 points at 2x resolution, means 60 times 2. It means that this image is 120 by 120 pixels. 60 points at 3x resolution means 60 times 3, so 180 by 180. And the math is pretty straightforward, right? So another example would be 40 points at 2x resolution is 80 by 80. 40 points at 3x resolution is 120 by 120. Is that fair? It's important. When I say things are important, I'm hinting to you that it may or may not be in the midterm. Cool. So when you're using graphical tools such as Adobe Illustrator, a tip would be to enter 72 ppi for resolution, points per inch. And those are references for you guys to take a look at. Oh, this link I actually put in there is actually pretty cool. I was super confused at one point on like resolution, screen densities, DPI, PPI, screen sizes, and this article really helped me out. It's by Paintcode. So it really distilled, sometimes I really need to know, like, does an iPhone 6, what's the resolution of iPhone 6? What's the resolution of iPhone 4? And it's not as easy to grab that information out there, but this is the one style guide that you can use to understand that for all these different iPhones, what are the points, what are the pixels, what's the size of the screen, and it's actually really useful. Yeah.
When you're adding a picture to your app, do you have to find all those different densities, or is there a way to simplify that?
So let's say I'm on I'm gonna pull up Storyboard right now. Let's do it. Let's actually continue with what we had before. I think it was my first app. I gotta name my projects a little bit better. Okay, that's a good one. Cool. All right, let's pull that up. So let's say this is going to be the most awesome screen ever, and I want to put an image, and I'm just going to drag and drop a view. So I got that through, I'm moving a little bit too fast. So I'm in Interface Builder. On the right-hand side, it's the Utilities panel. That's context specific based on what I've selected. On the bottom half of the interface of the utility panel, on this button right here, it's called the Object Library. And you guys can follow along if you want. If you don't want to follow along, that's okay too. The Object Libraries allows me to select user interface elements that I can drag and drop in Interface Builder. So remember at the end of last class, I found a button that I liked and I just dropped it in the screen. Sometimes I don't want to, keep scrolling because my time is super valuable and I just don't want to waste it. So what I do is I can search for elements. So in the very bottom of the screen on the bottom right, you see a filter bar. You can type in the name of your user interface element that you want to search for. So I'm going to search for UI view, and I'm going to drag and drop a view. So a view is the most basic object, and I'm going to give it a color so that you guys can see it. So let's say I want to put an image right there, and visually right now it looks a little bit too big. I want to make it 50 by 50. So maybe this is a profile page, and this looks right to me. And I click on it, and I know that this is 50 points by 50 points. If I want this to be displayed on an iPhone 6 Plus, how many pixels would I need for this picture? So this image right here is 50 points by 50 points. Now I want to make an image for it, and I want to show it on a 3x display. How big should the picture be in pixels? So yeah, that's the question, is how many pixels? Yes.
150 by 150.
Exactly. So 150 by 150. But my job's not done because I want to be a good mobile developer. I want to also display it on 2x displays. What would the image size be? To 200 by 200?
100 by
100 by 100. Yeah, exactly. 100 by 100 pixels. So first you design the way you want it to look visually. Then you look at the points, and then you just do some multiplication by 2 or by 3 to know how many pixels your image should be. Does that answer your question?
Yeah, I mean, would this also be the same for like an image you downloaded from Google?
You'll have to resize it. If you want the most optimal experience, you want to take it to Photoshop or just resize it to the actual image dimensions.
And then when saving it in those different folders, how does one do that?
Cool. Yeah, so I'll walk you through how to do that a little bit later. So I'll walk you guys how to insert an image, because you have to do that for your first assignment. Any other questions about images, screen densities, sizes, points, pixels, resolution? All right. All right, let's talk about user interface components. Part of being an awesome iOS developer is knowing what user interface elements are available to you. So Apple has their #1 library. It's called UI Kit. So Apple engineers have spent thousands of hours building this library called UI Kit. And inside of this library are user interface elements that we would use. There would be buttons, there would be labels, there would be switches. What else? There would be segmented controls. There would be text fields. So a lot of iOS engineers at Apple have slaved away to build this library for us to use. So part of our journey here is understanding what are the user interface elements that are available to us, and how do we take advantage of them, and what is the intention behind them. So let's take a look let's jump right to it. So you guys probably know Apple is super popular. You know, they have world-class design, and people have spent thousands of hours really thinking about user experience, user interaction, what makes a clean interface, how should your design be laid out. And they put all of their hard work, all of their research into this human interface guideline. So it won't hurt you if you spend an hour reading it, because people have, this comes from the think tank of Apple, and they want developers to create better interfaces. So if you peruse through this, you would see their best ideologies about, you know, the spacing, the clarity, you know, how you should have depth and design principles to just browse through this. So the human interface guideline is super popular, and overall it should make you a better designer. All right. So almost all iOS app needs to use UIKit in some capacity, right? You almost always have an interface that your user would interact with. So knowing what are these objects, what do they do, what are their properties, and really understanding them would take you very far in building user interface elements. When someone tells me to build an app, I look at the screen and I dissect all the user interface components. I know every single one of these buttons, every single one of these labels. I know the classes, I know the properties, I know the methods, I know what they do and what they're capable of. So when you start to practice more and more iOS, you will start to see these things differently. So I would tell you that this is an image view, this is a UI label, this is a UI alert view, right? This is a UI button, this is a UI table view cell. So you start to see these things differently. And we're going to explore what each of these elements do. They fall into categories. You have your bars, which provide you contextual information about where you are. And it has common buttons that allow you to navigate and have action items, the call to action items. You have your user interface elements, which are pure content. Whether it's a label or an image, they just display data. And then you have your user interface elements, which are controls, which are action items. So the user can tap on a switch or toggle a slider. And then you have things which appear temporary. So like an alert message that they stay very briefly, they want to grab the user's attention, and then they dismiss themselves. So let's look at, so this is just a recommendation for you guys. Try to have buttons that are big enough for your thumb to tap on it, because this might seem silly when you look at them side by side. You know, this is obviously the better user interface decision, but a lot of people I've seen have tried to cram buttons or make things very, very small. And that is not great user interface, right? So you can have one button that can hit, you can have one thumb that can hit 3 buttons or 2 buttons at the same time. You want to have space, you want to have breathing room for your users. Cool. So let's talk about bars. The first bar on the top is the status bar. It tells you the time, the battery, what operating system or what device you're in, whether it's an iPad or an iPhone. It can be transparent or it can be opaque, but it always is at the very top. You can also hide it if you want. Right below the status bar is the navigation bar. So you see this in probably like a mail app. This would give you a sense of where you are in the middle with the title. It also gives you the ability to go back sometimes, or it has an action item that you can tap on. Toolbar is typically fixed to the bottom, and these are all action items. These are things that you can act on in your current screen. So right here, we're in the Mail app, and we have the ability to create a new email, to reply, to share, to drop it in a folder, or to delete it. Toolbars on an iPad are also, because they're much wider, they have, right here, this toolbar has 2 different sets of buttons. So here's the universal imagery that Apple actually provides you in Storyboard. So you don't actually have to design these icons. Apple gives them for you that you can use it's a click away, and I'll show you guys how to use these later on. But these are the universal symbol for adding, for trash, for organizing, for reply, and you kind of want your app to follow these principles, because if I'm a user, I've already seen the trash button 10,000 times, and I know that this means delete, right? You don't want to create your own new icons that confuses people. You want to kind of follow the design that has been made for you, at least when it comes to these simple things. So a tab bar is translucent. You can see it in like your music app, I think, in Apple Music, where each one of these, if you tap on it, would lead you to a different section of the app. And that's what it's usually used for. And I think the rule is for an iPhone, you can have 4. And if you have more tab bars, then it would have a button that's more, and then you have this list that you can choose from. On an iPad, you have more real estate to use, so you can have more buttons in your tab bar. So this is something that constantly, as mobile developers, you think about. How would it look on an iPhone versus how would it look on an iPad? We're front-end developers. We think a lot about interface and how it can adjust to different screen densities as well as screen sizes. Some more icons. So the search bar is, it's a text field that allows the user to search. They can enter text, and typically you see that little magnifying glass as universal symbol for search. This is a variation of the search bar. It's called a scope bar, and it allows you to search with your typical text field and your text. It also allows you to have these little tabs that limit the scope of what you can search for. All right, so that's all about bars. Next, we're going to look at content views, and the content view's job is to display data. So an image view. So we're going to get into that. I know you guys all really want to have images in your app. It's your first assignment is to have an image in your app. An image view, the sole purpose in life of an image view is to display an image. So that's basically all it does. All right, so controls, label. A label is just a text, and it just displays data. It doesn't expect any user interaction. It just displays data. That's text. Segmented control is basically a bar where you can tap on it, and it's basically a mutually exclusive control. So if I select standard, it would deselect hybrid and satellite. If I select hybrid, it would not allow me to have both things selected. So that's a segmented control. A slider is a nice little user interface that allows you to oscillate between 2 different values. So maybe you can have a number that's like 0 on the left-hand side and a number that's 1. And as you're sliding, you can have different values for your floating point number. Stepper is a neat little UI that basically allows you to increment or decrement a value. Switch. It's a switch. It allows you to turn on and off. So the actual data behind a switch is a Boolean value because there can only be 2 states. A button. I'm sure you guys know buttons since you were little, so I don't need to introduce a button. Text field allows you to enter a piece of text. So in iOS, there's a difference between a text field and a text view. So a lot of students get tripped up over that. A text field is something that you enter, you're supposed to enter small snippets of data. So like your first name, your last name, your password. It's supposed to be 1 line. A text view is, it allows you to enter text, but it's supposed to support big paragraphs of information. So like if you're editing like Wikipedia, the title would be a text field, but the body, the content would be a text view. So a lot of students confuse the two because they're very similar in their name. It doesn't help that they rhyme with each other too, so you kind of get them mixed up. But a text view allows you to modify big chunks of information in a text view. A text field allows you to have one snippet of information, like a person's name, zip code, credit card information, password. That's for a text field. All right. So temporary views. There's really two types of temporary views in iOS. One is the alert view. This is basically a pop-up. Try not to do this too much because it annoys people, but it's an alert. You have the ability to have a title as well as these action buttons. Sometimes you can have a title as well as a description in the second one. Sometimes you can just have a title and two buttons. Sometimes you can have a title and a button. It's very customizable. So you can have different alert views. Action sheet appears at the bottom, and it's all buttons. It's all big buttons that allow you to perform actions. So you guys have probably seen this before. A modal view is a view that takes over the entire screen. So when we say something presents modally in iOS, we mean that it takes up the entire screen itself. All right, another important slide. There's three types of UI controls. One is static. Static means that it doesn't expect user interaction. It doesn't do anything. So things like images and labels, they don't do anything, right? So this is a image view. This is a label. They don't do anything. They don't expect you to like mess with them. And that's static. Passive are user interface elements that still don't do anything, but they expect user input or contents change over time. So this text field, these text fields are passive. If you're typing on them, you're changing the internal contents of it. So don't worry about outlets and actions. We're going to cover that, I think, week 4. Yeah. Active are user interface elements that actually run a piece of code when you interact with it. So if you hit login, you can imagine that it makes a call to a server. It runs some piece of functionality to authenticate the user. So some function is run for actions, for active UI controls. Cool. So that is interface components. Any questions about interface components? Cool. It's a lot more fun when you dive into it. So let me dive into a short demo right here. Okay, so I'm back here, and let's say I want to add an image. And I'm going to go back here, and I actually have an image right here. The first thing I want to do is go to my storyboard. Right here. Go to my storyboard. This is the screen I want to focus on, and I'm going to delete everything. And what's a view that allows me to display an image? What's the name of the view? Image view, exactly. Perfect. So what I want to do is go to my utilities panel. At the very bottom is the objects library, down all the way until I find an image view, which is right here. So if you double tap on it, it has a nice little description for you, displays a single image or animation described by an array of images. So that's perfect. So I'm going to drag and drop this image view here. And let's say I want to change the dimensions of this image. There's a few ways I can go about it. I can, as you can see, there's these little boxes, and they're just asking to be dragged. So I can drag this box to the image that I wanted, to the size that I feel like it should be. Notice on the top left, it tells me the width and height in points, not pixels. Everything you see here is in points. Nothing here is in pixels. So let's say I can drag and drop, I can drag the image view this way to adjust the size. Or I can go to my utilities panel, select on my image view, and on the right-hand side, there's this ruler right here, which is the 1, 2, 3, 4, 5, the fifth icon. Yeah, the fifth icon, and it's called the size inspector. So if you click on it, on the top right, it shows you the frame of the view. So remember how we said every view has a frame, and the frame is the XY, which is the origin, and the width and height, which is the size. So I can actually set this to, let's say I want the X to be 20, and I want the Y to be 20. And let's say I want the width to be 200 and the height to be 200. So I want an image like that, and I'm happy with how it looks. So if I want this at 2x resolution, which is, every one of you guys, if you guys don't have a plus, you probably have 2x resolution. So a 3x resolution, remember, is a 6 plus and an iPad. iPads are 3x resolution. So if you have an iPhone 4, iPhone 5, iPhone 6, iPhone 7, you're at 2x resolution. So if I want this at 2x resolution, I need an image that is how many pixels? So if you guys can read it, this is 200 points by 200 points. Trying to exercise your brain here a little bit. So this image is 200 points by 200 points, and I want it to show properly on my 2x resolution device. How many pixels would this image be? 400 by 400, exactly. Cool. So I kind of contrive this because I have exactly that image that's 400 by 400 points. So the place where we store images in Xcode is a very special folder called assets.xc assets, as xc assets stands for Xcode assets. This is the place where you dump all your images, all your resources for your Xcode. Before they had that, you had to put it in your file system, and that was confusing to a lot of people. They decided to centralize it with one folder called assets.xc assets. So what I'm going to do here is I'm going to drag USC circle, which is 400 by 400 pixels. And notice that I didn't just name this USC circle. I named it USC circle at 2x to indicate that this is supposed to be 2x resolution. Because just because it's 400 by 400 doesn't tell me, do I want this 1x, 2x, or 3x? It can be any of them. So in the name, I indicate that I want this file, and I want it at 2x resolution. And then I made a smaller one, which is usccircle.jpg, which is 200 by 200 pixels. If you want to, nothing's stopping you. You can put at 1x, but conventionally people don't put at 1x. They just put the name of the image. Cool. So if I take these two images and I drag and drop them right here, notice that they fall into place. Apple knows that this image is at 2x, and Apple knows that this image is at 1x because they both have the same file name, USC circle. It's just their suffix is different. So it's able to show me that, hey, I have the same image. This is 2x resolution. This is 1x resolution. I don't have anything for 3x resolution. So some of you guys might be wondering, what does this look like on an iPhone 6 Plus? Would it just not show an image? Would it be empty? And the answer is it won't be empty. Apple would just take 2x and it would scale it, it would drag it to fit that space. It would look pixelated, it would look a little bit blurry, but it's there. Cool. So I have my image here, and the name of the image is USC circle, so remember that. And if you want to change it, you can hit enter, you can hit return, and you can change it to anything, really anything you want. So I'm just gonna call this USC. So the name of this asset is very important because this is what I'm going to use to identify in Storyboard. So I'm going to go back to Storyboard. I have my image view here. All right, so anytime you want to change any user interface element in Storyboard, you always select it, go to the Utilities panel on the right because it's context specific, and on the top you go to Attributes Inspector, which is the fourth icon, this little tick mark right here. And this panel right here, you see every single thing that you can change about this image view, all the properties. So everyone always comes up to me and asks, like, how do I change this label? How do I change this text field? I want the font size to be different. And I always tell them, click on your UI element, go to the utilities panel, go to the attributes inspector, and these are all the different properties you can change of your UI elements. Cool. So I can change something like the background color. So I can click on this, and I can click on this wheel, I can click on this color wheel, and I can change the background color of this image. This is actually really cool because they didn't have that before, and I had to use Photoshop. 90% of my usage of Photoshop is using it as a color picker, which is very sad. Don't tell your designer friends. I just use it. I just use the color picker of Photoshop. But now Xcode has it, which is really cool. So you can choose a background color if you want, but we don't really care about the background color because we just want an image. So as you can see right here, there happens to be a text field for image, and I'm going to type in the name of the image, USC. I'm going to hit enter, and there's my image. So it's looking pretty good so far, actually. What if I decide to, drag the box around a little bit? So that's not what I want sometimes. So if I drag the box, what happens is the image is going to stretch in whatever shape or form to fill the frame. So you can tell that the frame of the view is right here, right? The frame is the XY and the width and the height. So the image is going to do whatever it takes to fill the frame. So what if I want the image to maintain its aspect ratio? There's two ways I can do this. If I go to content mode, notice that it's scale to fill. I can change it to aspect fit. Aspect fit means you have an image and you have a frame. Your image is right here. Your frame is right here, as indicated by the blue area. Scaled aspect fit means maintain the aspect ratio of this image, but show the entire image. So fit this frame, maintaining the aspect ratio. So that's why it's called aspect fit. Sometimes you still want to maintain the aspect ratio, but you want the image to fill the entire frame, and that's aspect fill. So if I click aspect fill, it's gonna, and let me do this. If I click aspect fill, it's gonna fill up the entire frame, maintaining its aspect ratio. So these are two very, very popular ways of, two very popular content modes of your image view, which is aspect fill and aspect fit. One keeps the image inside of the frame, and the other, the image takes over the entire frame, maintaining its aspect ratio. By default, your content mode of your image view is scale to fill. So the image view does not care at all about its aspect ratio. So I can just do, so I have seen a lot of apps with a lot of flat faces because of this, because it's scale to fill. So it's just one click away really to aspect fit, and then you have an image that fits, that maintains its aspect ratio. Cool. So let's run this. I'm gonna hit Command R to run, or you can hit the play button. Oh man, that's not a good error. Okay. Let me quit this. Okay. And it's loading. All right, when all else fails, restart your simulator. Oh, okay. So this brings another interesting point. this was the screen that I had in the previous demo, but I'm very clearly, I'm designing this screen right here. If I zoom out in my interface builder, I'll notice that there's actually two screens in my interface builder. The one that I designed in the previous class on the left-hand side, and the one that we're focusing on right now. This is definitely not what I want. I wanted to show that screen when the app starts up. So in order to do that, notice that there's a very obvious arrow right here. That points to the first screen that should display after your app launches. So all I have to do is move this arrow into this screen. And if I run the app again, this is the first screen that will load up when my app starts. So there you go. Cool. Looks like I created a flag for USC. It's like it's 3 colors. It's like white, blue, and it's like a flag. Cool. All right, so let's take a look at other user interface elements. So in your homework, you're gonna make a profile page for yourself, and something else you're probably gonna need is a label. So I'm gonna drag and drop a label, and I'm gonna call this ITP 342. I know it's very boring. So this is the label. I can double click on it to add new content. So ITP 342 fall 17. So what if I want to change the font size of this label? What if I want to change the font family? What if I want to change the color? What if I want to change the alignment? Anything that I want to change in my label, I'll click on it. I'll go to the right-hand side, Utilities panel. I'll go to the Attributes Inspector. If I click on it, I see all the options that are available to me that I can change. So let's say I want to change this to red. I'm going to give it like a little red. Let's say I want to change the font size, make this a little bit bigger. Let's say I want to center it. I can click on that. Yeah.
How do you code? Do you usually make the layout like this, or do you do it through like a text? You have to do it like you type it.
So yeah, so that's a very common, I guess I want to say misconception is, a lot of people, they think that you're an iOS developer. You build user interfaces in like code, right, all the time. And the truth is we use this pretty extensively. We use Storyboard very extensively. We make use of the visual editor for the visual interface. Now, when it comes to the app logic, we will write the code for it. But when it comes to interface, it makes sense to have a nice interface builder to build our interfaces. If you're actually very curious on how this works, this storyboard file, I did this once and it didn't end up too well for me. So let's hope. Okay, so this storyboard file is actually backed by XML. Underneath the hood, it's XML. So if you go to open with, and I'm only doing this for you, open with text edit, you see that this is the XML, right? So would you want to do that? Or would you want to drag and drop a label, right? If you're an Android developer, you might do that more often than you would like. If you're developing Android, you write a lot of XML for your user interface. If you're an iOS developer, you get to play with the cool stuff, and you get to, drag and drop these labels. And
so when referring to these icons, you have IDs that you can just link on the right over here, or
you have IDEs.
IDs,
Right, yeah. So we're gonna. Oh, that's a very excellent point. So how do we reference them in code? Basically, do they have some sort of identifier? And we're gonna go over that in week 4. We're gonna go over that. Yeah. So this week we're focused on visual interface, everything visual. Next week we're gonna focus on all code, and then the week after we're gonna bridge them together. How do you link the code and the interface? It's all been thought out. It's all been planned. It's not. We're not improvising here. Yeah. Okay. Cool. So. Okay, so a few things I changed. I changed the font size, I changed the color, I changed the alignment, and now I'm going to move this around. So labels, they don't only support one-liners. You can actually have paragraphs that are labels. So I'm just going to be kind of generic here, and oh, I can use this. Yeah, I'm just going to copy this. I'll just copy this. All right, so I'm going to copy this paragraph, and I want to put it in my label. So I'm going to paste it. And the first reaction is that the frame goes off screen. The label is, there's so much text that it stretches out. It stretches out horizontally. So the first thing I want to do is make sure that the width is within the screen itself. I can drag and drop the frame right here. I can drag it, or I can be a little bit smarter, go to the ruler. And right now it has a width of 3,259 points. Let's get it down to 200. Okay. Cool. So this is my frame right here. By default, labels they only allow one line of text. So if you want more lines, you would go to the attributes inspector, and then you can see that there's a text field for lines. And I noticed that the default is 1 because it supports 1 line. So if I want to increment this to 2 lines, I'll hit the little up arrow. If I want it to be 3 lines, 4 lines, I can keep on going. But this isn't really a scalable solution because sometimes you have dynamic text. You don't know exactly how many lines does that text fit on that screen size in that font size. So you want something a little bit more dynamic. And that's when you can set the number of lines to 0. And by setting it to 0, it would fill up the entire frame of the label as many lines that it can fit. And if it doesn't fit, it would truncate it. You can see this ellipsis, the 3 dots after, what's that word? Immersive. So after immersive, it's truncated. But what if you don't want to truncate half a word? You can actually go to Attributes Inspector and right here, one of them, line break, you can truncate not the tail of the word, you can do a word wrap. So the word wrap would allow you to basically truncate the text, but not truncate the middle of the word. Cool. So when you guys are doing this for your assignment, you want to set number of lines equal to 0 because you're going to have a profile of yourself, and that's going to be multiple lines, unless you have a very short profile. Yeah.
Is it possible to make it scroll?
Yes, scrolling in iOS. It's probably like middle of the semester. Yeah.
Okay.
Yeah. That's you think it would be easier, but we actually have a view specifically for scrolling, and it's called a scroll view. You need a little bit more understanding of like views to work with something like this. Cool. So we have 2 labels. We have an image view. So something I want to point out here is iOS is object-oriented in nature. Everything you see here is an object. This label is an object. This label is an object. This image is an object. If I drag and drop multiple labels, I'm instantiating, I'm creating different objects. So when this app runs, there's going to be 1, 2, 3, 4, 5 label objects and 1 image object. Every object you see here is a full object. It has properties and it has methods. So part of your journey as an iOS developer is looking at that and seeing what are the properties, what are the attributes, what are the methods of these objects. So the image has a class name. It's called a UI image view. So if I go to the Apple documentation, I look for UI image view. Cool. So it gives you a nice little description, an object that displays a single image, and it gives you a whole discussion about JPEGs, PNGs, and how images are scaled. We talked about aspect fit, aspect fill, scale to fill. So thanks to this class, you don't have to read this. But you can keep on going down. And then really quickly, you're going to see properties. So this syntax might seem a little bit weird right now. It's on Swift. So if we go to the top, we can choose our language from Swift to Objective-C, which right now it might be even more strange to you, but it's okay. So this is what we're going to be focusing on. So if you scroll down, you see these are the properties. The image view has an image property. It has a highlighted image property. It has a method called start animating. It has a user interaction enable property. Now, so I have to say Apple documentation is one of the best documentation I've ever read. If you guys have read Java documentation before, it really feels like they don't care about you. It's like really bad documentation. Apple really tries to make this accessible to you. So notice how these things are organized. They don't just throw the properties on the top and the methods on the bottom. They actually organize them conceptually by, what do you really want to do? Do you want to initialize an image? Do you want to access the image? Do you want to animate images? Well, these are the properties and methods that have to do with animating an image view. So they categorize based on intention of a class. What do you want to do with this object? And that is a really amazing thing for developers, especially when you're new to this. You don't want to read through that entire list of 100 methods and 50 properties and look for that one property that might have what you want. So take some time in looking at these views and looking at their corresponding classes and seeing what you can play with them. A lot of students would come up to me and ask, like, can you do this with an image? And I would point to the documentation. They'll find it and they'll see, oh, okay, the answer is in the documentation. I can animate images. So there's that. All right, cool. So that's a little demo. Let's see, what do we have here? I want to go over auto layout. We have a little bit of time. I want to go over auto layout with you. This would overlap a little bit with Trina. She's going to be covering auto layout. But auto layout is a topic that a lot of people struggle with. So I kind of want to at least try to help you guys out with auto layout. All right, so we're still talking about images, things that are visual. When you're an app developer, you want to think, how do I make it so that my app would look visually the same, horizontally, vertically, on an iPhone, on an iPad? You want this to be responsive. And when if you guys have designed websites before, there's responsive web, right? There's responsive designs, there's fluid designs for web. So for iOS, it's the same. So like I stressed before, every element on the screen is a view. Specifically, it's of type UI view. So that's the class name of a view. It's a UI view. If you look at the documentation, they would call this a UI view. Every UI view has a very important property called the frame. And as I discussed before, a frame consists of an origin, which is the XY coordinate, and dimensions, or the size, which is the width and height. So this is a UI view object. This is the origin, and the width and the height is the dimension, or the size. Every single view has it. In fact, UI view is really the parent class of all of these classes. So in your CS101 class, you guys probably learn about inheritance, right? You have these children classes that inherit functionality from your parent class. So UI view is the parent object of all of these classes. Buttons, labels, segment controls, text fields all have frames because the UI view parent class has a frame. Okay, so this is also important to understand when we talk about views. Views can have relationships between each other. So let me do a quick demo on that. All right, so we're moving on to screen 3. So I'm going to grab a new screen. In iOS, screens are called view controllers. So I'm going to search for a view controller. Drag and drop. All right, and I'm going to search for a UI view. And I'm going to make this one, I'm going to give this one a blue color and this one a red color. Okay, so views have relationships to each other. And right here, this screen itself has one view. So this if this is the window, there's a main view right here, and that's the parent view. This is the, and I can show you guys that I can click on this view and I can give it a background color of gray. So there's a difference between the window and the view itself. So if I were to go to a place like Google Chrome, right, there's a difference between the actual window, which includes the tabs, the bookmarks, and this main view right here. So likewise, when you're looking at a screen, there's a difference between this window and the main view, which is this black view. So currently, blue and red are sibling views. There are views that are next to each other. What you can actually do is you can put a view inside of another view. So I can actually take this red one and then drag it into the blue one. And now the red view is a child of the blue view. The red view is the subview. The blue view is the super view. And it might not be obvious to you from looking at this, whether or not red is inside of blue or red is just on top of blue, whether or not it's a sibling view or it's a parent and a child view. So this is where the document outline comes into play. If you're in the interface builder, on the bottom left, there's this little drawer right here. If you click on it, it's the document outline. It's basically another way to visualize your view hierarchy. So if I'm going to click on this, I can see that I have 1 view, 2 view, 3 view. And it's confusing to me that they're all named views. So I'm going to give them a name. So I'm going to hit return. I'm going to call this the red view. I'm going to hit return. I'm going to call this the blue view. I'm going to hit return. I'm going to call this the gray view. You can name this whatever you want. It doesn't actually have an impact at runtime. It's more for you as a developer to give it a name that that has meaning to you. So I can see very clearly that the red view is inside of the blue view. It's a child of it. And that has implications. So if I click on the blue view and I click on the frame, if I set the origin to 0, 0, you would expect it to be at the top left, right? Because 0, 0 is the origin. If I set it to 2020, you would expect it to be a little bit offset from the top. So if the red view is a children, is inside of the blue view, and if I set the origin of red to be 0, 0, notice that it's relative to its parent. The red view isn't at the very top of the screen because it's inside of the blue view. If I take the red view out of it, so it's no longer nested as I see in my document outline, and if I set this to be 0, 0, it's at the top left. It's no longer inside of the blue view. So, but if I put it inside of the blue view and I set the origin of this to be 0, 0, it's relative to its parent. Does that make sense? This is really important when you have a very complex screen. So like if you were to build the Facebook newsfeed, you have to understand like parent-child relationships and how things are positioned, because there's a million views going on at the same time. You need to understand how things are positioned relative to each other. So parent, child, sibling views. Okay, cool. So we have the super view, which is the view that contains other views, and then the subviews is the views that are being contained. So this was supposed to be my blue view. This is my red view. Red view. Red view is a subview of the blue view, which means that blue view is the super view, and the red view is the subview. If I have another view down here, let's call it the green view. This is right now it's not holding anything, so we can just call it a view. But to the blue view, it's a sibling view because it has the same level right here in the view hierarchy. It's not inside of it, and it doesn't contain it, so it's a sibling view of the blue view. So we talked about frame. I said frame like 10 times already. It's the X, Y width and height. Typically, what you care about is the frame. There's also this special property called the bounds. And the bounds is the internal coordinate system of the view itself. Right now, the frame and the bounds are exactly the same. But when you deal with scroll views, the bounds is significantly different than the frame. So with a scroll view, actually, I don't want to confuse you guys. The scroll view we'll talk about later. So for now, bounds and frames are exactly the same. The special case is the scroll view because you're displaying a specific frame, but you can scroll around a vast area. So the internal coordinate system is much larger. But we'll talk about them later on. So the center is the center point of the view. If you move the frame, you move the center. If you move the center, you move the frame. So you can write a little script that animates the center, and the frame would follow. Cool. So when we're laying out user interfaces, there's 3 approaches to laying them out. We can programmatically lay them out using math. No one likes that. No one wants to do math. We can use springs and struts, which is an old way of it's a more dynamic way to lay out your interfaces. Or we can use auto layout, which is by far the most recommended approach. Springs and struts have a very rich history in iOS, so it deserves at least a slide or two. So with springs and struts, what happens is you have a view, and let's see here. You have a view, and you specify what happens to this view when the parent view changes. So an example would be, if my blue view grows wider, I want this red view to grow wider with it. So springs and struts, it's always a relationship. Springs and struts, it's always a relationship between the parent and its children. As my parent changes, I want this view to change accordingly. And that's fine, except for one very blatant issue, is what if you have 2 views right here, and let's call this, I guess, do you guys prefer names or letters? Is it easier? Names? Okay. Let's call it orange view. So if I use springs and struts, I can say, if the blue view changes, I want something to happen to this red view. But I cannot say I want this orange view to always be below the red view. I can't specify relationships between the sibling views. And that's very bad because sometimes you're going to see views overlap each other, and springs and struts does not provide you with a mechanism to have relationship between views. And guess what? That's auto layout. So common tasks in springs and struts are painful. If you want a label to always be below an image, you can't do that. You can only say that the label would always be fixed to the bottom of the parent view. It's always a relationship between the parent and its child. So auto layout came along in iOS 7, which is probably ancient for you guys. And it's a system where you define how views should be laid out. It's the preferred approach by Apple. It's been recommended several times. If you see someone that's not using auto layout, you should laugh at them or like frown upon them and like don't be friends with them. Have them talk to me. They should be using auto layout. And I actually worked with people that did not use auto layout, and they're very bad developers. Cool. So as the name implies, auto layout would automatically determine the frame of a view at runtime. And the way you do it, so this is one of the hardest topics for a lot of students, and I think it's because they don't really think about it much. So the way auto layout works is that you have a view, right? You have an innocent looking view right here, and you give it a bunch of rules. And you give it a bunch of rules on how it should behave. And these rules are called constraints. So you give it a bunch of rules about how it should behave, and at runtime, it should obey those rules. It should stretch, it It should shrink. It should do whatever it needs to do to follow the rules that you give it. You give it specific rules. And with auto layout, you need to give it enough constraints for the view to know 4 things. Every view needs to know 4 things. And that is the X, Y, where I'm going to be positioned at, and the width and the height. How much space am I taking? This is, if I can put 1,000 stars on this, I would. So every view needs to know these 4 things in auto layout, and that's it. If you really focus on this auto layout, you got it. It's a system where you write a bunch of rules, not too much. You write rules for the views, and every view needs, based on these rules, it needs to know the X, Y, width, and height. It needs to resolve its frame, and that's it. Okay, so before we get into the nitty gritty of auto layout, I was like a little too excited there. I got a little bit deeper, but let's talk about like times when your app changes interface, when the screen real estate changes. It can be due to external changes. If you're building a Mac OS app, the window can be resized, right? That's external to your app. If the user is using different screen sizes, if the user is running, Facebook on their iPhone, if they're running on an iPad, that's an external change. If the device rotates, right? So if the device goes from here vertical to horizontal, that's an external change. When someone gives you a call, that's an external change. A bar would appear, bringing your layout, your interface down. Cool. Internal changes is when content itself is dynamic. So let's say you have the Facebook newsfeed, and you want to display the same Facebook newsfeed but in Chinese, right? The characters would change the entire layout, right? There's much more characters. There might be much more characters or less. So internal changes is changes to your content. Yeah, cool. And iOS has something called dynamic type. Where is it? Right here, dynamic type. Dynamic type means that users can select, if they're visually impaired, they can select different font sizes. So you would display like a bigger font size for people who ask for that in the iOS settings. Cool. So let's take a look at auto layout in a more visual manner. So right here we have 2 views. Nothing too scary here. We have view A and view B. And I'm going to give these views a bunch of rules on how it should behave. The first rule I'm going to give it is that this view should be pinned to the left by 20 points, no matter what happens. Like, no matter what happens to your world, you should always have the leading space of 20 points. You should always be pinned 20 points. That would resolve the X of the view. The view would always know it's X because I've told it to always be pinned 20 points. I give it a height of alpha. That would resolve the height. I also tell the view that it should be pinned to the top by 20 points. That would resolve the Y. No matter what happens, you should always have a height of alpha. You should be pinned to the left by 20 points, pinned to the top by 20 points. So all of these 3 are checked. So what's the last thing that the view needs to know that I didn't go over? Width. So a view needs to know 4 things: X, Y, width, and height. So I haven't gone over width. So I'm going to add one more constraint here with a trailing space constraint of 20 points. No matter what happens, your trailing edge needs to have 20 points of spacing. And this would resolve the width. If the view is always pinned to the left by 20 points and always pinned to the right by 20 points, if you rotate this horizontally or vertically, the width would resize. And that's where the auto and auto layout comes into play. So let's actually do a quick demo of this. So don't worry about the second view yet. Okay, let's drag and drop a view. And let's give it a color. Okay, so there's a lot of different ways you can add constraints. A very popular way is this tool right here. There's 3 tools. There's 4 buttons, and they all have to do with auto layout. So it would make sense that auto layout is inside Interface Builder because the whole thing builds the interface of your app. So at the very bottom, you have 4 icons. And on the 3rd icon, if you hover over it, it tells you that you can add new constraints. So if I click on it, I can set what we call spacing constraints. So I'm going to uncheck this box, constrain to margins. Always uncheck this box because it typically adds unnecessary padding that you don't need. So always uncheck it. So I'm going to add a top spacing constraint, a left spacing constraint, and a right spacing constraint. And I'm going to set this to 20, 20, and 20. So imagine you selected this view, you've hit on this pin icon right here, and then you have these 4 things. Right here, I'm setting the leading space constraint to be 20. I'm setting the trailing space constraint to be 20. And I'm setting the vertical top spacing constraint to 20. That means this view would always be pinned 20, 20, 20. So this would take care of my X, this would take care of my width, and this would take care of my Y.
You've been a quick question.
Yeah.
So I know in responsive web design, you often play with percentages for margins. Does that ever come into play with that part?
You can do percentages. You can, yeah, for sure. Typically doing these numbers are like fair enough for most cases. But you can do percentages. They're called multipliers. I'll show when we get deeper into our layout. We can do that. Yeah, sure. Okay, cool. So I'm gonna add these constraints. Before I add it, I actually want to add one more constraint, which is the height constraint. So the height constraint gives me a specific value that I set the height to. So I'm going to check this, and let's say I want the height to be 200. So with these 4 constraints, I satisfied all 4, right? The view knows its X value because I've told it that it's pin 20. The view knows its Y because it's pin 20 from the top. The view knows its width because it's pin 20 here and pin 20 here, so it would always stretch to obey those 2 constraints. And the view knows its height because I explicitly told it that, hey, I want you to have a height constraint of 200 points. So it knows all 4. So what I'm going to do is add 4 constraints, and notice that the view automatically resized to obey those rules that I gave it. And if I run it, I need to make sure that this is the first screen, so I'm just gonna do that. Cool. So what I'm going to experiment here is I'm going to rotate the device. And notice that it followed all the rules that I gave it, right? It's fair, right? I've told it that 20 points on the left, 20 points on the right, 20 points on the top. You have a height of 200. So no matter how I change my interface, no matter how I change externally, it would always obey those constraints. And this is how you design responsively in iOS using auto layout. Cool. So what I did just now is not different than springs and struts because I had a relationship between this view and my parent view, and that's what springs and struts is all about. It's about your parents and your child views. What's special about auto layout is your ability to define constraints between sibling views. So here I have another view, and I gave it a leading space constraint of 20. It's always pinned to the left. I gave it a trailing space constraint of 20. It's always pinned to the right. I gave it a bottom vertical spacing constraint of 20. It's always pinned to the bottom. And I gave it a height constraint of alpha. What's interesting here is that I also have a spacing constraint between these two, so that this view would always be 8 points below that view. And that would guarantee that our layout would never break that constraint. They would always try to obey that constraint. They would always have 8 points of spacing between them. So let's do that really fast here. Let me bring a view here and let me give it a color of red. So I'm going to do exactly what I did before. I'm going to hit this add new constraints button. And then I'm going to set a leading space constraint, a trailing space constraint, a bottom vertical spacing constraint. So you can tell that I can toggle them. I can highlight. If I highlight, that means I want to create the constraints. And I'm going to enter the numbers 20, 20, 20. And I'm going to add it. So there's one more constraint I want to add, and that's the relationship between my red view and my purple view. To specify a constraint between them, I would hold control and control drag from the red view into the purple view. So control drag, so I'm going to do it again. Control drag into the purple view. And then here are all the constraints that I can use. So I'm going to use vertical spacing. So right here, the constraint is a little bit big. If I want to modify it, I can click on this actual constraint right here, and I can change the constant from 89 to 20. If I run my app, both views would obey all the rules that I've given it. So I rotate it like this, rotate it like this. Notice how this is interesting, because I've said that this view, this purple view, should have a height of 200 points. But I've never give my red view a specific height. So notice how it shrunk to preserve all the constraints that I've given it, right? You can't be mad at auto layout because you made the rules, right? You told the view that it should have 20 points of spacing in between, 20 points of spacing on the left, on the right, on the top, and on the bottom. So when auto layout doesn't work the way you want it to, you gave it the rules, right? So so that's a quick demo of auto layout. I know it's probably a lot. Trina's actually going to cover this again in Monday. So I think this is a topic that's worth covering twice at least, because there's a lot of moving parts. Cool. The last thing I wanna say about auto layout is this. This is going to be key to your success in auto layout. I just kind of threw the constraints out there because I've been working with them for a long time. I just threw out vertical spacing, trailing, leading, bottom, top. It's your job to understand what are the constraints that are available to you. So if you're going to play with the system where you give your views these rules, you want to understand what are the rules you can give it, right? So these are all the different rules you can give it. These are all the different constraints that you can specify for reviews. There's spacing constraints, there's alignment constraints, and there's dimension constraints. And it's not that bad, right? It's 2, 4, 6, 8. If you know what every single one of these constraints do, you're equipped with the knowledge to really use auto layout. So try to understand, what does leading mean? What does center Y mean? What does center X mean? Take you very far in auto layout. For your first homework, you actually need to use auto layout to make sure that your app works if you scroll horizontally as well as vertically. Like all the UI elements are visually shown. That things don't get truncated when you flip it. So one more thing. So I want to talk about the first homework you guys are gonna have. So this week you're gonna have homework. Next week you're gonna have a homework as well. But next week I'm not gonna be there, so I'm just gonna go over a little bit of what you're gonna be doing next week, and then Trina is gonna follow up with that. So this homework is going to be it's all about you. It's gonna be assigned starting tomorrow. It's gonna be available on Blackboard, and then it's due Friday, September 1st. So you have a lot of time. I'm not gonna go over you can read all you want in your own time, but I'm just going to go over this. This is what you want to build. Right? So this is your Hello World app. You want to build an app that has a UI like this with your name, profile picture, and a little profile about yourself so we can get to know you. And you want to make it so that it would fit as you're scrolling. You don't cheat by making the content so small that it works like any orientation. Like try to use auto layout. Don't be afraid to use auto layout. And so you want to have your images in the right resolutions. You want to have 2x, 3x resolutions. You want auto layout. What are the UI elements here? Image,
Text,
label, yeah. So UI label, UI image UI label. So perfect. And one more thing I actually want to cover that I didn't, that is going to be doing your homework, is app icons. You want your app to have an icon. And how do you do that? You go to assets.xc assets. Notice that there's a folder already created for you called app icon. And this is exactly what we saw on the slide. So we want to have an app icon for our iPhone app running iOS 7 to 10. So if we have an app icon that's 60 points at 2x resolution, that would be 120 by 120. At 3x resolution, it would be 180 by 180. So what we're going to do is I have exactly that icon. It's 180 by 180 and 120 by 120. So I'm going to drag this into here. Oh, sorry, this is the wrong bucket. It's right here, this one. And I can drag and drop into right here. Right here. And I'm going to run the app again. Okay, so you can't see the app icon right now because you're seeing the app. So if you want to go to the home screen, you can hold Command Shift H to go to home screen. And that's my first app. That's my first app with my icon. And as you can tell that I provided a square image, but the rounded edges are provided by the iOS operating system. So I don't need to make rounded edges. So you want to include that in your app as well. So how we format homeworks is we have a definition of the requirements that is needed. So right here you can see that we need at 2x and at 3x, 120, 120, 130, 180 by 180 for your app icon. We want these UI elements. So these are the requirements. You have to test it, zip it into a zip file, and upload it to Blackboard. So we actually had students that zip only the Xcode project file. So let me show you guys really quick. Let me show you. Let's see. Playground, iOS. So every Xcode project is going to have Xcode project file is going to have this file. It's going to have build. It's going to have the name of your app. You don't want to send only this one. A few students have only sent this one. This is the configuration for your Xcode. Your actual files are in there. So if I click on audio demo, those are the actual files, right? So some students have only sent the Xcode project file, which is not enough. So you want to zip this folder that contains these 3 files. Okay, so zip this folder that contains everything. Cool. All right, and the last thing is, this one I thought was kind of funny, but also very true. Points will be deducted if your app looks exactly like the sample app. So don't take a picture of this and put like a big image view, or don't write Trina's profile pic, and we want to get to know you. So don't write your name as Trina Trojan. So that's your first homework, which is going to be due September 1st. Your next homework is going to be assigned next week. It's good, and you're going to have a week to finish it. So let's see. Labs 1, 2. All right, this one is pretty fun. This one's pretty cool. Okay, so this next homework which is going to be assigned next week. And so you guys don't have to think too much about it now. I just want to show you guys this because I'm not going to be here next week. But it's going to be called Choose. It's going to be a little bit more advanced. And you want to build an app where you have two options. You have basically two options to choose this item or this item. And then you write in the text field, and if you choose this item, you have a label that reflects this is your name and this is the item you have chosen. So you have a little bit of logic there. It really depends on how far we go. Looking at this, we might not do this next week. We might do it the week after. But I just want to show you guys the next assignment. So some students have done Pirate or Ninja. That's a really popular one. So as a ninja, you are one who perseveres and overcomes, even with a blade at one's heart. It's pretty intense. Yeah. So you want to have a text field. You want to have these buttons. You tap on one of them. Your label reflects. It's smart enough to know what the actual input is in the text field, and it's smart enough to know which button you have pressed. So that's your second assignment. Cool. So all of these things you can read on your own time. Let me see if I have any other announcements to make. I've already recorded the video lecture for next Wednesday's class. The only thing I haven't gone over in that video lecture that you guys might be interested in is Swift functions. I actually have a video on my From Scratch TV for that, so that video is going to do a better job than me right now explaining Swift functions. So watch that video for Swift functions. Monday, come here for class. Trina's going to be here. The best, nicest iOS teacher you'll ever meet, nicer than me, which is unbelievable. So yeah, so I'll see you guys in a while. Like, there's Labor Day, so it's going to be 2 weeks until we meet again. All right.